right, welcome to the True Data Ops podcast. In this episode, I'm your host, Kent Graziano, the Data Warrior. In each episode, we'll bring you a podcast covering all things related to data ops with people that are making data ops happen today. Now, if you've not yet done so, please be sure to look up and subscribe to the DataOps.live YouTube channel. That's where you're going to find all the recordings from our past episodes. If you missed any of the prior episodes, you still got plenty of time to catch up. But better yet, go to truedataops.org and subscribe to the podcast. Then you won't miss any of the future sessions. Now, my guest today is Dr. Santona Tuli, who's actually a real scientist. She has a PhD in physics and nuclear science, but she's also, more importantly for this show, she's an expert data scientist and data engineer, and she's the director and head of data at Upsolver. Welcome to the show.
Thank you, Ken. Thank you for having me.
So, yeah, you and I met very recently here back in end of January in Austin at Data Day, Texas. One of the biggest data shows in Texas that, I discovered a number of years back there held at the University of Texas. Great opportunity to meet and mingle and listen to some of the leading thought leaders really in the data space about all things related to data and AI and, everything that we talk about these days. So it was great to get to meet you there. I'm glad you're able to come on the show. So, but for the folks who weren't there, maybe you could give us a little bit about your background in data management and what you do at Upsolver.
Yeah, happy to. So as you said, I'm a physicist by training. Physics and math is sort of what I learned in school, and then I worked in. Oh, hi, LinkedIn user. Someone on LinkedIn says hi. I got my PhD from UC Davis, but I was working with the heavy ion group at the CMS experiment at CERN, which is we were analyzing data from nuclear collisions to answer questions about the strong force and early universe, what happened after the Big Bang. So that was a lot of fun, and it was also a lot of data. Really massive data sets, both at the time of creation of the time of generation. So like the data engineering challenge of how do you process data that's created so fast was really fun. And then even when you do collect some subsample of the data, cleverly subsample of the data, you still have so much data between that and the signals that you're looking for, which are vanishingly tiny. So a lot of data reduction, feature engineering, really fun work. And then finally, some simple ML modeling to actually extract the signal from the background. So I did that end to end a few times over. And then the last analysis I was leading, the Paralympic people physicists, and we ended up doing a baseline comparison for various kinds of effects, and it helped in constraining some of the parameters in the strong nuclear force equation. So it was nice to see sort of the effect of that as well. And then moving on from my physics career, I did some work as an NLP ML engineer, where I started thinking about sort of operationalized production workloads in an industry context. Obviously, we were working at CERN with like really massive data and really important questions, but there was always this fallback of we can review this, we can revise this, and make changes or improve this and publish new papers on it. Whereas in the industry, it's often sort of, it's out. Your users are consuming the product that you're working on. So a lot of learnings there. And then since then I've sort of gotten deeper into tooling. So tooling in the data space. I worked at Astronomer as a data scientist, which is a managed airflow service. So workflow orchestration. Thinking about how do we build the best version of an workflow orchestrator so that everyone can get value out of it. And on that thread, I'm now at Upsolver, which is also a it's someone called it earlier today a computational data lake, which I think is actually a really good one. So we offer a data lake as a like a fully managed service on top of Apache Iceberg, and we also have a Hive version. And you can do declarative transformations within that data lake, as well as access it through any query engine or warehouse or database that supports Iceberg.
Wow. Okay. Well, that's quite fascinating. So, part of your your PhD study, you were leading that team at CERN, studying it. If I read this right, it was ultra relativistic collisions. Right. That's what was. So, you're going to have to explain, to this non-physicist exactly what the heck that means. What's ultra relativistic? We're familiar with the theory of relativity, E equals mc squared, and all that, but what's ultra relativistic?
Yeah, I mean, when you get closer and closer to the speed of light, like you kind of have to come up with new words for describing the range that you're in. So that's where the ultra part comes in. But yeah, I mean, we accelerate or at CERN, we would, and other particle accelerators and colliders, sort of start with, everyday material. So in our experiments, would start with a little capsule of lead, pure lead metal. And then starting from there, extracting away the electrons so that you're left just with the ions, and then accelerating those over and over again. So you've got a linear accelerator, and then you have a circular one, and then a bigger circular one, and a bigger one. Ultimately, you're at within the main tunnel in the LHC, and it's going at very, very close to the speed of light. So that's where the ultra relativistic part comes in. And then the collisions happen, and this collision medium that's produced from that heavy, like really high energy deposit is many orders of magnitude hotter than the center of the sun. So it's, the scale and stuff are kind of really fun to think about sometimes. And of course, it vanishes really quickly as well, because that much energy deposited in one place, like it creates really heavy particles that you wouldn't see in everyday situations, but you did see after the Big Bang, and then those very quickly decay into their daughter particles, and those decay and so on and so forth. So the whole thing also vanishes really quickly, and the trick is to capture everything that happened within that very quick, very energetic collision using a bunch of detectors around that collision point.
Wow. Yeah. So part of that is that generated a lot of sensor data, and you said you're basically doing had to build data pipelines to handle like multiple terabytes of data back when you're doing that. So tell us a little bit about that experience specifically around the data, what it taught you about managing data at that scale.
Yeah, scale is such a funny thing to think about. So the data at the time of production were coming in at petabytes per second. So that's a whole other challenge of how do you even you don't have the bandwidth to collect or process or store that kind of data. So how do you come up with use your physics knowledge and prior knowledge about the detector to design a filtering system that works at the hardware level, that filters out the events that you're not interested in and only lets through the data that's actually that you're going to use in your analysis, and that's going to be impactful. So that's one challenge. And then the data comes in, and when you're eventually doing your analysis after the data have been processed a few levels, it's still like tens, 20 terabytes of data usually per data set that you would analyze to make some sort of meaningful conclusion. And usually it's a few together that would give you a complete picture of different kinds of physics. So the massive data challenges are both similar and different from smaller scale data challenges. So this is what I mean. They're similar in that sorry if you hear a puppy barking.
Yeah, you hear the puppy. That's okay.
Yeah. So the
That's going on behind me now.
yeah.
Squeezing the yard work.
The similarities, of course, are like when you're thinking about data ops, right, or operations within a pipeline, is the thing that you care most about is that like it's sustained process. It has high uptime. It's highly available, right? Like this you don't just want the thing to happen that you have planned for to happen or written to happen, but that it like doesn't crap out in unexpected or weird ways. I'm gonna have to keep going back to it. So again, like I guess the saving grace for the big particle physics data was that we, in some senses, we had the um, uh, flexibility to go and run the analysis again. Now, of course, it's computationally very expensive. You're definitely like you don't want to make mistakes, but because it's a lot using up a lot of compute every time it runs, but also it's better to be right and wrong, obviously. Um, and then and part of it we didn't have that saving grace, right? Like when the data are coming in real time, we have to be able to do something or trigger on the data and collect the data, because otherwise you've just wasted like literally billions of dollars in accelerating these and colliding these protocols. So it's um so I think of operations as like I can't get away from thinking of operations at the hardware level as well, and at the real time level as well, because that sort of we would sit in the control rooms when the first couple of days of data collection, and like just be there. Everyone on the team would be there ready to respond, and that like sort of incident response is very ingrained in the way that I think about data ops as well. Um, so there were lots of lessons learned, I think, as a physicist that helped transfer over in terms of how to think of operational data pipelines that have really helped me.
Yeah, so it's like in seven pillars talk about monitoring as well as automated monitoring, automated testing. And that sounds like that was definitely a big piece of what you needed to do, especially, I mean, not only you're talking about data at this massive scale, but the massive cost of creating the data, right? Not even collecting the data, just the massive cost of creating the data using the accelerators there, like CERN, makes that pretty critical so that you really kind of get your operational ducks in a row, as it were, right? To make sure
Right.
that
Yeah. Yeah.
most
Exactly. Exactly. Because in industry, the data is sort of being created, and whether or not you collect the data and sort of monetizes is kind of a weird word, but like get something out of it. Like people are your customers are using your product, and they're going that all of that is going to happen. Whereas in an experimental setting, you're explicitly creating or having an event that then creates the data. So yeah, monitoring
And of course, it has to be reproducible as well, right? Because this is science. You're doing
Yep.
experiments, and you have hypotheses, and you want to test them and retest them and compare the results, I guess, from the various tests to try to come up
Yep.
with your conclusions. Yeah.
Yep.
So yeah, I think so. You guys probably are pioneering things in the data ops world before anybody even thought of the word data ops.
I mean, I don't know about that. I mean, it's been a few years, so I don't even feel that comfortable, sharing that sentiment with the folks that are currently at CERN. But I mean, yeah, there are lots of pioneering technology that did come out of CERN for sure. But yeah, I mean, the pillars of operations definitely like it's the same, right? It's sort of you have to. I mean, um so the two things that you mentioned just now, so monitoring, absolutely. So when I said we would sit in this control room and I'll be there, like screens everywhere. We actually there's a movie that I've shared before. It's called Secrets of the Universe, that our research group got to like take part in, where there's some scenes where you can see there with all the screens that are in the control room that are showing in real time, like with all the detector sectors, and how many of the detectors are working correctly, how many are down, because sometimes that'll happen. You can't just go in while the particles are colliding and switch out a detector part, right? And then sometimes you can't even do it like in a few month time scale, because there's, enough runs are commissioned that these have to happen, that you just sort of, okay, this is a known issue. And that's another, like, thinking critically about errors and error modes, like in what ways can things go wrong, and what do we do in these very specific when things go wrong in these specific ways, and also like, what are my known knowns and what are my unknown? That sort of like way of thinking is super important.
Yeah, I forgot you'd been in that movie, Secrets of the Universe. I think on your LinkedIn profile, there's the clip of you. You've actually, I think you had it on your profile somewhere. I found it because I watched that clip. That was pretty interesting. Having you talk about that. Where does that movie show up? Is it like on Netflix or somewhere? Where where people can find it? It's
No, I
fascinating.
believe it's still only shown at select IMAX theaters. But there's a website, Secrets of the Universe, where you can go to see clips and other stuff, and also where it's being shown.
Okay, good. So that's secretsoftheuniverse.com. Yeah. So yeah, encourage people to go take a look at that, especially, everybody's watching this podcast is into data. And so as she's been explaining here, that there's a lot of data involved in studying the universe. So that's a fascinating field. So I want to switch gears just a little bit here. One of the hot topics out at Data Texas was, of course, talking about data products. This is kind of a new concept that got popularized with the advent of Shamak Kagani's theories on data mesh. What's your take on data products and how it fits into the data environments that we're dealing with today?
Yeah, I think it's super helpful as a framework to think through data and data deliverables. So the way that I think of data products is like the specific deliverables that are consumed on a regular basis. So very similar to an operationalized user-facing product, where you have to think about the maintenance and day-to-day and serve something relevant and fresh to the end users. It's the same idea, except your data products are probably going to be used internally almost always, but you still need to come at it with the mindfulness of there are users, even if it's just Steve from the finance department. There are certain expectations that Steve is going to have and need in order to be able to do his job well, that rely on this data deliverable that he's looking at on a regular basis. So it can be dashboards, it can be reports, it can be just data sets that are in some way processed that like help get to an answer quickly. And especially at larger teams, if you have sort of like different teams owning different parts of the pipeline, which is a reality that I like. I like to have end-to-end ownership, but the reality is like at a certain scale, you sort of have to split it up. Then the data products would also be the things that are handed off to the next team. And again, it's all about the SLAs, right? Like what is the agreement you have between the producer and the consumer, and what are you doing on the producer side to maintain those agreements, and what are you doing on the consumer side to like how are you following up on that like living relationship with the producer side, because things can change and will change, and you can't just be like, oh, you broke this, I was expecting this schema and you broke it, and it's done. Like you can't. It's something that you have to like collaborate on and work towards. So I think data products are
more of a collaborative feedback loop.
Yep, exactly. But it's the product mindset, I think, is extremely important. And I've been, delving into product more and more as I progress in my career. And the sort of, it's not even like a rigidity of thinking. It's like a clarity of thinking. I think that product folks have, that like they're very good at like defining the whats and the whys and stuff. And bringing that into a data practice is actually quite revolutionary. Like I've seen it happen in front of me. It's don't do it for the sake of doing it or for the sake of the technology or because, it's flashy or something like that. Do it because it serves some purpose for someone else. That mindset is priceless.
Yeah, I think as technologists, we tend to think of the how, and sometimes don't think about the why, right? And I think it is very valuable. I mean, even in early agile days, you had product owners, but now it's starting to get adopted even better. I think, like says that interface, really with I'll say the business requirements. Why are we doing this, right? We're collecting this data. People want to analyze it. Well, how do they want to analyze it? Why are they? What's the value of doing this analysis and making sure that we're delivering on that rather than, which data pipeline tool are we using, right?
Yep.
We pick the data pipeline tool based on as you said, the SLA, the data contract, the requirements of what we're trying to deliver, and be more focused on that rather than on necessarily using the latest tool off the shelf, right? It might not be the right thing to solve the problem. So yeah, I think that's a good perspective. I do like that. I mean, we've got, you work for a software company. I used to work for Snowflake. We had product management, right? Even from a software perspective, you had people they were thinking about what's the end user experience with our software, what problems are we going to help them solve? And then the engineering department had to figure out how to make that happen. And if we start doing that in the data world with, like you said, delivering data sets, if it's, like you said, end to end, consumer on the other end, or to intermediate stages, I like that in bigger organizations. Certain things, people own this part of the data and have to deliver it at a certain cadence with a certain level of quality, but you still have to have that feedback loop, right? We know that, are the customers getting what they need? And the customers might be another data engineer in your organization, right? It might not be an end business user.
Right. Yeah. Yeah, exactly. And I mean, being mindful of the end user is really important as well, right? Just as you said, like if my job, if there's this, let's say there's a centralized data team, and within the team, my job is to produce the relevant data products for other teams, let's say marketing, finance, etc. And each of those teams have their own like mini data engineering function, right? Maybe it's one person, maybe it's a couple of people. Then it's the data product is going to look different based on like the technical level, the data expertise level, and so on and so forth of those individuals. And it has to be a collaboration because no one wants to be given something that they don't have like any flexibility with or autonomy with. Like that would be an uninteresting job, right? If someone were to say, okay, this is exactly the KPI that you're looking for, this is what you need, you sort of run with it. That's not how that works. It has to be a conversation, a back and forth. And all of these, like, that's why I like data products so much, is all of these are actually product ways of thinking as well. It's you're doing the user research, you're sitting down with with whoever you're going to be serving. Like we call them stakeholders in data world, but even more, I think, higher level is like users, the folks that want something out of the data organization, and you discuss with them their needs, their wants, or even more broadly, their problems. Like, what is the top thing that you're trying to solve right now? Whether or not it has anything to do with data, let's put that aside. That's secondary. What are you working on? What are your, three mandates for the next 6 months? And then starting from there, sort of filtering that down into, okay, where can we come in? Where can we help as a data organization? And then going from there to actually drafting something that's close to a PRD, like a product requirements doc. Because we do, like, I think another thing we do not very well as data teams is documentation. I mean, this is across the board, kind of like, and you could say who does documentation worst, and you can't find an answer to that. But at least on the engineering side, it's sort of one of the core pillars. But I think as data scientists, like, which we didn't come in with that sort of software rigor necessarily, and not that it maps perfectly well, But I do think that sometimes documentation can be a weak spot for data folks and data teams. And so starting at that initial requirements gathering level and really documenting all of that, thinking of it as a PRD, then turning that into an engineering requirements documentation. How are we? That's where the fill comes in. Is how are we actually going to solve it? And then going from there and building out the data products. That sort of strategic and organized thinking is very good.
Yeah, and the challenge is, of course, doing it in an agile manner so that it's not taking years to do these things. That if we're going to deliver useful products, that we got to do it in a much shorter time period. And when you say BRD, it takes me back to early days of my career where we spent literally months meeting with people and writing up BRDs and getting sign-offs and all of that before we ever turned it over to engineering. And that just, projects literally took years. And as we all know, by the time we built anything, the requirements had actually changed because the business had changed. And that was, I'm talking a couple of decades ago now. Things move so much faster now. There's just no way you could get away with it because things would just be changing so fast that we have to be even more agile in building the products and keeping, it really boils down to me, scope control, right? It's making sure that we've scoped the project to something that's doable in short term that is going to deliver some value.
Yep.
So
exactly.
Automation. What's your take on that? And do you think we're going to see more like AI assisted automation in trying to deliver this? Because I think at this kind of scale and speed, I don't know how we do it without any kind of automation.
Great question. So top level, I'm very pro automation, right? I mean, that's the name of the game with any sort of software product is you're making abstractions and you're doing automation so that individuals have to do less of the repetitive work and can focus more on the creative aspects of the job. So yes to automation, and that's why I like workflow management tools. I like the sort of storage management tools, and so that at the end of the day, really what you should be thinking, as a data developer you should be thinking about is the thing that you want to get done, not the house, and it should be optimized in the back end anyway. With that said, the other part of your question was AI. And not to say something controversial here, but I'm a little bit careful when talking about AI, because I think it's still because I'm afraid of overhyping it. But maybe I should reformulate how I think about that. But basically,
I'm with you. I don't disagree with you on that.
Yeah. I think we're getting there. I think we're getting there in terms of leveraging AI automate some of our work. I do think that these the functions that we have today, that folks have today, are not going to go away, but their jobs are going to get easier because there's, and sort of a coding helper is an example of that, right? It's sort of just something that helps you do the thing that you're trying to do. So I think we're getting there where that's going to be more prevalent. But I'm a little bit I guess the one thing to say is that it's not going to replace every part of the function, and that's the point, right? Is again the sort of a lot of the creative outlets and a lot of the clever problem solving. I think at least in the short term is going to be left to humans, and super interesting. And I think most people are saying, so I don't have something totally interesting to add in this discourse here. But maybe the one thing I'll say is, even if the entirety of it is done by AI, that's that's a big if, but that would be not a bad thing, right? Because we're in a post scarcity economy, basically, so we can just go do the things that we want to do, that we get true enjoyment from. And if that's writing data pipelines, great, you can ignore the AI and just write your own pipelines. Or if that's reading a book under a tree, then you can go do that, because the AI will take care of all the other stuff.
Yeah, I think we still have to be involved on at least on either end, saying what the AI is going to do and reviewing what it did do, right? And doing our due diligence, making sure that we're actually achieving the goals. Back to the monitoring and testing, right? I think even if we automate generating all of our code, which
Right.
I think it's entirely possible in the next number of years. We're going to see, even more of that. I mean, code generators, as you know, have been around for a long time. Now we're getting these kind of co-pilot things and, a natural language interface where we can tell it what we want it to do and it generates the code for us. There's going to be quite a bit of work still in making sure that the code is really doing what we wanted it to do. And part of that is understanding, how to talk to the AI, right? To articulate what you're really trying to do, what you want it to do. So yeah, I think we'll get there. But like you said, automation, we definitely got to do automation in order to handle the amount of data and the speed at which we're having to do things. There's no way around that. Organizations that have, a bunch of engineers who are the only thing they're doing is coding. You have to code everything by hand. I suspect, they're going to fall behind in the long
run. Possibly. Like, I'm not. Yes, I mean, I agree with what you're saying, but with the caveat that you don't have to. Like, if you are today finding yourself sort of coding with 95% of your day as coding, that doesn't mean that you're going to be, irrelevant in 5 years. It just means.
Oh yeah. No, as an individual, no.
It's just like it's time to think about the strategic level as well. So actually, that's I know we have a question up here, but I mean I've been thinking about this recently. Is how do you divide up the kinds of roles that exist in a business? I think like I always work at startups, so I like usually thinking very cross functionally and stuff. And I think it comes down to like strategic and tactical. And I think a common mistake that folks make is think that tactical is execution and strategic is not execution, and that is just completely false. It's if you're doing it at the tactical level, you might be doing more execution. Like, so for example, if it's in the coding field, you might be doing a lot more coding, but a strategic role then not just like saying, oh, this is what needs to be done. There's a lot of work, execution involved in doing the due diligence and doing the experimental work, the sort of hypothesis testing work that gets you to, okay, this is the right decisions strategically that we need to take. So it's a tangent, but that's something that been sort of top of mind for me recently.
Yeah. Okay, you want to take this question?
The work you did at CERN is at a different scale than what you did after. Do you miss it? There's excitement in both worlds. What excites you the most now? I miss parts of it, but like I think a lot of the parts that I miss, I can still like talk about, and like it was fun while it lasted, and I'm very happy for those experiences and for those learnings. So an example would be like working with such massive data and like the kind of the pressure of this better not break as we're starting the run, because then it's like again, many billions of dollars wasted and a month of detector time wasted and stuff. There are parts that I do not miss, mostly having to do with again, there's a pro and a con. So for at least at CERN, and I know this is true at a few other places as well, the reviews are endless. So going back to what you were saying, Kent, about like getting sign-offs on PRDs and stuff, getting sign-offs on an analysis, it's like a chain that is never ending. So you have you review from the working group, and then from the bigger working group, and then from the collaboration, and so on and so forth. So the and part of, again, that's good because you really have to have high confidence in the results that you're publishing when the signals are so rare, and like you're talking about like fundamental laws of physics. But on the other hand, part of it does become bureaucracy. Part of it becomes like, oh, someone wants the color to be changed on a plot, and that sort of thing happens as well. So that I don't miss as much.
All right. Well, we're kind of ran out of time, which I kind of figured we would because you got so many interesting things to talk about. Are you going to be speaking at any events in the near future where people might get to hear you talk about some other things?
Yeah, so I'm a little bit I have conference fatigue a little, so I've been staying away for the last couple months, a little bit, but I will be at Snowflake Summit where I'm not doing a talk, but I'm planning to do sort of a hallway chats thing, especially with because Absolver is very invested in Iceberg right now, and I mean a lot of people are talking about Iceberg, and Snowflake Summit is going to have some cool Iceberg talks as well. So the plan is to sort of catch those speakers and experts like after their talk to have a deeper drill down discussion or like takeaways kind of discussion. So I'll be doing that in the Snowflake Summit, and a few other conferences that I'm gonna be at, but nothing like super immediate coming up.
Okay. So yeah, if you want to catch up with what she's going to be doing here, here's her LinkedIn profile. Please connect, and you can. I assume you, like everybody, if you're speaking somewhere, you're going to post about it, and so people will find out that way.
Yeah,
Okay.
exactly. Yeah.
Awesome. Very good. All right. Well, fortunately, we got to cut the show now. So, but thank you so much for being my guest today. It's been wonderful having you on. Great conversation. Love talking about things that a little different occasionally. Getting to talk about relativistic physics and nuclear science, I think is very cool. And the fact that there's data everywhere, right? And we're dealing with data all the time. So again, thank you very much for being here today. Thank everyone else for joining the show today, live stream, or if you're watching it on a replay. Be sure to join me again in 2 weeks. My guest is going to be industry analyst, advisor, consultant, and the founder, CEO of Bark, Dr. Karsten Beck. As always, be sure to like the replays on today's show and tell all your friends about the True Data Ops podcast. And don't forget to go to TrueDataOps.org and subscribe to the podcast so you don't miss any of these future episodes. So until next time, this is Kent Graziano, the Data Warrior, signing off for now.